Alright, December the 2nd. Alright, let's go for it. Minimum time visiting all points. So, another easy problem. On a 2D plane, there are endpoints with integer coordinates. Okay? Return the minimum time in seconds to visit all the points in order given by points. It can move according to these rules. In 1 second, it can either move vertically by 1 unit, or horizontally by 1 unit, or diagonally square 2 units, move 1 unit vertically and then 1 unit horizontally in 1 second. You have to visit the points in the same order as they appear in the array. You're allowed to pass through points that appear later in the order, but these do not count as visits. Okay? So points is a 1, 1. 3, not really. 1, 1, 3, 4, minus 1, 0. I might get code later, but at the moment, it feels okay. So 1, 1, 2, 3, 4 is 2, right? And 3, 4, 2, minus 1, 0 is go up, and then go down. I guess it doesn't matter which path you take, right? Because it's only diagonal, or let me see. So go up, go down. How about, what if we go down 1, 2, 3, 4? Oh no, you're here. You're at 3, 4. Oh yeah, I mean that's the only way. 1, 2, 3, 4. Otherwise, 2, 3, 4. Yeah. So you should do diagonal as much as possible, right? Yeah, so you should diagonal to given 2 points, doesn't matter. You always, unless you don't need to, if you don't need to do diagonal, you just go straight. If there's a need for diagonal, like if it's not on the same row or the same column, then you diagonal to that row or column, and then you'll go straight, right? So if I go 1, 1 to this, I diagonal from 1, 1 all the way to 3. I mean, yeah. So it's just a difference between, yeah, 1, 1, 2, 3, 4. Is that just a Hamming difference? Yeah, I think that's just a Hamming weight, right? 1, 1, 2, 3, 4. 1, 2, 3, 2, right? You need to go 2, so that's the 2. And then, oh, but then it's 1. Huh. Okay. Yeah, this is because they have ones the same. So if they are the same, right, if they're different, then you find out which one is closest, right? So x is 2, y is 3. So you do the x, right? So you do 2. It's basically 2 steps. And then once you get 2 steps, you plus, yeah, you find the minimum of the, find the minimum of the 2. Yeah, why would you go the maximum, right? If you go maximum in this case, you say I want to go from 1 to 4 vertically, so you have to go this way. Yeah, that just doesn't make any sense, right? It doesn't make any sense. Awesome. So you want the smaller, right? The difference, the x difference and y difference, the smaller of the two, and then you go that much, right? And then you do, yeah, I think that's the way to go. Give it a shot. Actually, I'm not 100% sure, but it's good enough that we can take a crack. Okay, let's do this. So we're gonna go through every single one. No, not really go through every single one. So res equals 0. I go from the second one, so I can go in front. So we say for int I equal to 0, I smaller than points dot length. No, you say second one. All right, so I can say x int x0 points I minus 1, right? 0, and y0 is points I minus 1, 1. Int x1, so I can, let's say, maybe yank this, paste this, and we just make some changes. So can I find, okay, question mark, I minus 1, and we'll do this, turn into I, right? Now we can do this, repeat the same, and we need to turn this into 1. Okay. Nope. There we go. All right, so we have all of that. Then we say a couple of things. If x0 is equal to y0, okay, then res or plus equal to math.abs x1 minus y1. Boom, no problem. Else if x, no, what are you doing? X equal to y, dude, that's not right. This should be x1. Yeah, completely wrong. This should be y0, right? So else if now y0 is equal to y1, okay, and then we'll say res plus equal to math dot abs x0 minus x1. Else, what's the else? There's one more else if. Not really. I think that's it. So I have an else. So this else is we need to find a minimum, right, between the two. Maybe we can do, I'm thinking if we can just say math.minimum of the difference. If math.minimum I get the difference, I still have to deal with the other one. So probably not. So I just say, compare x. Yeah, I think. Hold on, let me, so else if, let's say x, do we do ABS on this comparison? Yeah, we have to do ABS on the comparison. This and this, because it can be anywhere, right? So we have to do ABS on the comparison. So math.abs x0 minus x1, if this is smaller than math.abs, actually maybe smaller equal to math.abs y0 minus y1. Alright, so when that happens, so we need to do the x first, right? But once we do the x, because it can go both ways, right? It can go both ways and go left, or it depends on where the y is. Because the y can be up and down, right? Y can be anywhere. So if I say I move x0 minus x1, right? I move this much to somewhere. It doesn't matter, we just move there. And do we do... Then basically just from x0 we move to x1, right? So what I need to know is how does y go? Right? How does y go? So I need to do... Oh, this is a... No. It's fine. So it's basically the smaller of the two, right? The smaller of... So we have the difference, right? The x-axis will have a difference. The y-axis will have a difference. So we pick the smaller one, right? And I will move there, right? And isn't that just the bigger difference between the two? I just see that. It's just a bigger difference between the two. Yeah, because you have x has a difference, y have a difference, right? And you just take the bigger difference because the smaller difference will allow you to move the point to align with the other one, and then you just finish up. So this, I don't even think you need to do any of this. You don't need to do any of this. I think just rest will be plus equal to math.maximum math.abs x0 minus x1 and math.abs y0 minus y1. I think that is it. Right? I think that is it. Oh, wrong. So return rest. All right. Let's see. Is this right? I just input something I'm not supposed to input. Okay, AK0V. Okay, just go for it. Looks nice. Yep, that is the thing. So 1266. The distance, the minimum, right? The minimum steps to take, right? To go from points I to points I plus 1 is the bigger difference, bigger absolute difference between either the x or y coordinates. All right, so it's not too bad. 223 and this going here. Let's just double check on this. Move diagonally as much as possible. Yep, that's exactly the case. Yeah, so we have three easy ones, that's for sure. All right, so this one's done. Let's move on. Let's try this one. Find the value of the partition. You are given a positive integer array nums. Partition nums into two arrays, okay? Such that each element of the array nums belongs to either array 1 or array 2, okay? So, yeah, has to be completely split into two arrays. Both are non-empty, perfect. The value of the partition is minimized, and the value is defined as the maximum on the one side and the minimum on the other side. Here, max denotes the maximum element in nums 1, and the minimum denotes the minimum on the other one. Return the integer denoting the value of such partition. Ooh, interesting problem on first glance. Oh shoot. So we have let's sort it, might as well. So basically we're saying we are going to break this into two parts such that the maximum on one part is very small, and the minimum on the other parts is very big. Well, I mean, yeah, you break this way. Maximum on one part, minimum on the other part. 110, 100. Maximum on one part, minimum on the other part. So you sort it and you find, you just sort it, you find any consecutive. You find the smallest difference between consecutive values. Okay, I think that should be good. Right? And then it looks all right. All right, let's go with this one. All right, so what do? We will sort this. So we can use array.sort. Okay. And then we are gonna say, because you want a minimum, so I can do a maximum. I can say int res equal to integer.max value. And then we'll say for int I equal to 1, I smaller than nums.length, I plus plus. Every time I do plus, I always do minus first. It's ridiculous. And then we'll say res will equal to mass.maximum, right? No, minimum. Res and nums I minus nums I minus 1, right? So we'll do that and we'll return res. That shall be good enough. All right, let's take a look. Of course, we'll go through this. Let's do one more test. I mean, I think it makes sense, right? But let's just do one more. My favorite random number. These are not random numbers. It's just me pushing this keyboard. Like this. All right, if this one's correct, we're just gonna submit it. Yeah, I think this is right. Yep. Sort the values and find the minimum. Why it takes so long? Minimum difference, right? Minimum difference between consecutive values. It's on log n. Maybe there's an on. You think there's an on version? How'd you do an on? Okay, let's check this discussion and see if anybody else has some good ideas. For 0. Okay, if Lee says sort, then you just sort. Okay, I think this is actually a better way. Yeah, this is better than that's fine. Okay, so this one is done. Let's move on. Can do one more. Yeah, let's do one more. Special permutations. You're given a 0-indexed integer array, okay? Nums containing n distinct positive integers. A permutation of nums is called special if for all indices 0, so any index in nums, either nums I modulo nums I plus 1 equal to 0, or okay, so we say a permutation is not distinct. A permutation is special if adjacent values are, what do we call this type of pairs? Divisible, right? Adjacent pairs are divisible. And we want to find the total number of such permutations. And the length is 14. Nums.length is 14. What's the total number of permutations? What's 14? 14 permutation is 8.7 times 10 to the 10th. Yeah, that's not going to work. That is not going to work. So we'll have to do something smarter. Let's see. I mean, 236 right? So we just put something to be divisible with 2, and 2 is a prime number, so it has to be 6, and 3, right? That's 1. And we can put 6 at the front. Nah, you're not going to do it this way. It's not going to work. You put 6 in the front. Now you can say we can just swap, right? These two we can swap. Huh. Okay, we only have 14. Okay, we only have 14, so we can afford to factor every single one of them. Okay, and we only need prime factors. Okay, we only need prime factors, so we just factor everyone. We factor every single one. Okay, we factor every single one, so now we don't have numbers. We have a set of primes. Okay, everyone is a set of primes. So we need to rearrange them such that each adjacent one shares at least one prime. Right? That's what it means. They share at least one prime. So the prime numbers, we can sort them, right? 2, 3, 5. No, this one I'd say 2, 5, 7, 11, 3, 11, like that. You sort it, and not really sort it, just you become like this. It's not a set, it's become an array. And then, like, how do you know they share at least one? They share at least one. I mean, we can do, it's not that many values. It won't be that many unique, it won't be that many unique, right, prime numbers. Maybe it can be, I have a map with prime numbers, so I have 2, right? And then we get an index. So I say index A0, A1, A3, maybe A2, 5, maybe A3, like that, right? We get this. And some may have like repeated, right? Maybe we have another A0 here, right? So if we have something like this, what can we do? So this tells us that these shares, right? These share at least one. Because it's 14, it's fine. We just go through every single one, right? 2, does it exist? 3, does it exist, right? So we can do that. And they can be adjacent, so maybe that means these are connected, right? These are connected. So I can say A0 connects to A1. A0 can also connect to A3, but also A1 can connect to A3, right? So this is it's a connected graph within this graph. And what I'm trying to say is they can be neighbors to each other, right? These values can be neighbors to each other. These values, yeah, if they share something, then they can be, we have all sorts of permutations among them, right? All sorts of permutations among them. And then we need to identify some stuff that's a bridge to other values. So in this case, A0 can bridge to this, right? So how about like A2? How can A2 find a connection to this? Well, A2 can connect to A0, so that's why A0 can connect to A0. So that's how A2 connect to this, right? And so basically this is a thing, and A0 has to be on the outside because it needs to connect to A2. Right? A3 has to be on the outside so it can connect. I mean, it's fine. A3 is already in it, so this one doesn't have to. It's not really that straightforward. Oh, and 1. Oh, 1. Damn, everybody is 1. Everybody has factor 1, but it doesn't mean you can put everybody anywhere. Oh, that's not right. Has only one factor, that's not right. This is not right. Has a one factor, that's not right. It has to be it has to be divisible. It's very different. It has to be divisible. Your set of prime doesn't work. This does not work. It does not work. No. Okay, so I think it's simpler, okay? I think it's simpler. You don't have to do any of this because it's divisible, okay? It's divisible. So for A0, who can be neighbor of A0? A1. Who can be neighbors of A1? AN. Who can be neighbors of AN? And just list them out, right? So A0, let's say, can be neighbors to a couple, right? Can be neighbors to a couple. So if you, an A1 can be neighbors to a couple. So everybody can be, so A0, I'd say A0. So somebody needs to be on the first one, okay? So you pick someone to be the first one, right? You pick someone to be the first one. Then you have a bunch of options. Then you go to the next option, okay? And you see who can be, and you go to the next option, all the way down, right? And then you change to a different option. Then you go down, So I can say if A0 is at the front, okay, then I can have option, something. So then I say, if I have this at the front, let's say maybe A1, right, from A1 to the front. So like maybe it's a DP, okay? DP, A, and a length, right? If I have this at the front with this length, what is the result? But remember, A can be gigantic. Okay? A can be gigantic. But we only have 14 numbers. Okay, we only have 14 numbers. It doesn't really matter. It can be gigantic. Yeah, just leave it be. It's a gigantic value. But how are we going to code this in Java? How are we going to code this in Java? We don't. We use index. This is index. We have this at the front and this length, right? Next to the front and this length, all the way down, right? So if we say dp0 with length n, in, right? dp0n will give me some value. Well, dp0n will be equal to dp, whatever 0 is connected to, something n-1 plus dp something n-1, right? And then we try to find this, and at a certain point, someone doesn't have anything, right? It doesn't have anything. It cannot go back, right? So we also need a visited set. How are we gonna do that? 14. What's 2 to the 14th? That's small enough. 2 to the 14th is small enough. 2 to the 14th. Yeah, that's small enough. So we can So we can use a state, a bitmap with 14, with the length number of this, so we know which one has been taken before. So we all the way we go all the way down to the end and see if we have filled everything. If we have, then it's perfect. If we have not, then no, we're not. So what now? We're gonna create a 3-level. Yeah, we can create a 3-level array. Dude, a 3-level array. I wonder if we can do it even simpler, a 3-level array. All right, does Java have LRU cache? Does it have it? Yeah, you have to implement. I don't think they have it. Yeah, no, you have to implement it. I mean, it's fine. The stat, no. The state is not part. State is not part of DP. Now, this is DP. State is just to help you know if this we can take or not. Okay. If that's the case, then it's not too bad. It's just going to be a n times n, right? An n times n thing. So we need to create the graph. Yeah, we need to create a graph. Okay. So we have two things. Oh, this is a good one. This is a good one. Very good intermediate medium problem. So we have an int. That's not an int, right? That is not an int. Because I do not know. Because I will push it in. It is a graph. It is a graph. It's a list of lists. Current graph. I got a new array list. That's fine. And let's implement everything later. So we have a graph. Then we have a DP. Okay, so we need to do int nums, right? Graph or equal to new array list. And for int I equal to 0, I smaller than nums.length, I plus plus, graph.add new array list. Yeah, this is just to prepare, right? We prepare the graph, and then we need to go through the thing to fill the graph. You'll probably need to also prepare the DP. So DP new int nums.length. Yeah, we typed so much nums.length. I think I should just get it n. Int n equal to nums.length. Okay, so all the nums.length. You know what? I'll do this nums.length. C find h n. Next, do the same. right? And then it will be n. It's n by n. So dp is done, graph is done. So next is create a graph. Oh wait, hold on, one more thing. Int. Nah, it's not here. This is not here. It should be here. Int mod is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so create a graph. How do we create a graph? For in I equal to 0, I smaller than n, I plus plus. And then for int j equal to 1, no, I plus 1, j smaller than n, j plus plus. Right, so we have I and j. If nums I, oh, that's an interesting question. I don't know. What if a small j show, well, no, like 4 mod 2 is 0, but 2 mod 4, what's that? Is 2. Okay, so that's not bad. So if this mod nums j, we say equal to 0, or nums j, right, mod nums I equal to 0. Either way, if any one of them works, then we say graph.get I dot add j, right? And graph.get j add I. Okay, I'll create a graph. Now the graph is done, and we need to run a DP. We need to run many DPs because the first can be, many different options. Anyone can go at the front. So what we need to do is, let me define the DP first. So the DP shall be something like this. Private int DP, right? Oh, I have a DP already. Don't call it DP then. What do I call it? Let's call it memo. This is basically memo, right? It's not DP, this is memo. Therefore, let's find DP. This one shall be memo. And we can go here and then call this one DP. DP is gonna be index, and length, right? Index and length. Maybe you can write this first. So yeah, so give me the index, give me the length. Oh, one more thing. And state int scene, right? Scene is a bit mask to keep track of which indices have been used. Okay. So this one tells you the total number, right? Okay. So we say if int. I just realized there's no way for me to tell if it's I might have to use this. Otherwise I have to preset. But if I use integer, okay, then if I use integer, then I can use null to indicate that I haven't done it before. All right, that's fine. So we say if memo index length can be n. So this should be n plus 1. Okay, so we'll do this length, right? We say if this is not equal to null, then we return memo index and len, right? If it is equal to null, we haven't done it before, then when do we update scene? That's a good question. When do we update scene? Well, we'll update scene when we hit it, right? When we hit it. Or, when we hit it, or before we even enter. I mean, the easiest will always be when we hit it, we check scene, right? If this index is in scene, we just return 0. And if it's not, then we set it. Yeah, let's do that. So we check first. We say if it should be 1 left shift index, right? 1 left shift index, and this is and scene. If this is larger than 0, is not equal to 0, that means we have return 0, right? This means index has been used. Otherwise, scene shall equal to scene or 1 left shift index, right? And then maybe we do this one later, right? Then we do this. If it's been before, if it's not, that's not what we want. Paste it, right? Then we say scene is this, right? So we visit the current one. Then we go through the next for int neighbor of graph.get index, right? We need a result. Result. Well, I guess it's fine. We just say int res equal to 0, right? And then we say res shall equal to res plus dp neighbor len minus 1, right? And scene plus this mod. Yeah, I guess maybe I don't need this. Right? And at the end, we say memo index length will equal to res and then return res. Alright, so I'm missing one thing. Okay, I'm missing one thing, which is the edge case. So this blah blah, and then the edge case is when len is equal to 0, right? When len is equal to 0, hold on, we need it to go to the end, right? We need it to go to the end. So now let's say I am at the end, right? I haven't seen myself yet, and I am at the end. And if I am at the end, I do not need to go anymore. So I can just say if len is equal to n, right? And no, equal to 0, right? Because at the beginning we say is n, right? And then we say, no, maybe 1. Is it 1? The last one, right? We start from here and then we have 1 to go. Yeah, len should be 1, right? Len should be 1. If I am at the length 1, right? I have a current index, and it has not been seen before. I have one more left. When that is the case, that is one permutation, right? This is a one permutation. So if this is one, then I should say, do I also set memo? Let's set memo. Memo index len is equal to 1 and return 1. That's 1, right? Otherwise we keep going. Or we can just say if len is equal to 1, then we just return 1. So we don't have to set the memo. Yeah, I think I like that. I like that. If len is equal to 1, we just return 1. Right? So we don't need all that. Okay, let's page down. So now we're gonna recursion. Right, recursion. Not recursion, say dp to find the answer. So we can say int res equal to 0. Okay, then for, because everyone can be the front, right? Everyone can be the front. And for int I equal to 0, I smaller than n, I plus plus, I say res equal to res plus dp I, length is n. This way start, we have n left, right? The length was n, and seen at the beginning is 0. Nobody is seen, and we'll mod, right? And then at the end we say return res. Not sure. Okay, there are a lot of things that I'm not sure. I just realized I did not use int n at the beginning. Which means I don't need this. Ugh, come on, 38k. I don't need this one. Right? Is this right? Well, I'm not 100% sure, but... Oh, they didn't use this? Oh yeah, I don't need this because I have the graph. All I'm doing here is using the graph. I'm using the graph, so I don't have, so this one's not necessary. I would just check the scene and then go to the end. If I haven't, right, if at a certain point I haven't, so there will be 0, right, it will be 0, 0, 0, will be some value, and then it will get out. Yeah, I guess it's okay. It's okay. Okay, let's give it a shot. Give this a shot. Give this a shot. This one makes sense. It does. Now, what I am afraid of is still the mod. Okay, it's still the mod. You know what? I'm gonna take a check. I never really check it myself, but I do want to check. Oh, I'm already in JShell. So let's say int a is equal to 1 left shift 31 minus 1. Right? This is the biggest a plus 1. Yeah, this is the biggest a can be. So how about a plus a, right? How about a plus a mod, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, it overflows, right? It will overflow. So we carry the risk of overflow. That's why I'm kind of, I'm not comfortable with doing the memo. I mean, I guess the memo is fine. The memo you can do int, right? Memo is okay. Memo is okay. it's the result. It's the result that's I'm uncomfortable with, which means this I would like to go with long. I want this one to be long, right? And then because this is long, so there's no overflow here, and all we need to do is this I remain it as an int, and let's just return memo index and len, right? We do that, and this one's the same. I am not comfortable with this being an int. We'll do long, right? And then here we're just gonna do int it. Okay, so let's get back 40k. Just to be right, but that's, you know, 2, 4, 8, 16, 32. And you see what I'm doing? Actually, no. Because 16, 32 divide. No, it is. Everybody's divisible by everybody else. 64, 128, 215, 6, 512, 4, 48, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's actually a good one. That's actually a good test case. It's gonna be tons and tons. Yep. I think it's not bad. Maybe this will work. Oh. Oh, it was a different problem. I thought it was gonna time out. Oh, we passed some. All right, let's dig in. What is the issue in this one? 250, 20, 100, expected 48. That's very different. That's very different. Anyway, so we have 20, 100, 50, 5, 10, 70, and 7, right? So it's a 0, 1, 2, 3, 4, 5, 6. So 0, 1, 4, that's it. So 1 have 0, 3, 4, 5, 6. So 1 has 0 and 4 has 0. So 1 have 2, have 3, has 4, right? So 1 has, so 2 has 1, 3 has 1, 4 has 1. Okay, so 2 will have 3. So 3 will have 2. 4, right? Oh, there's some. No, 4 will have this. Okay, it's fine. So 4 will have 2. So 3. I missed 0. Dude. Yeah, let's debug this. This is not gonna work. Let's debug this. 20, 100, 50, 5, 10, 70, 7. special perm nums. Okay. Where? Yeah, just put it here. Alright, debug. Where's the graph? One, three, four. Zero, 1, 3, 4. Yeah. One, 0, 3, 4. That's what is 2? Oh, I think did you type it wrong? Yep, I think I typed it wrong. 50, not 59. So 18J, find 59, then it should be 50. Okay, so let's turn this off, redo this. Yeah. 0, 1, 2, 3. Yeah, I think this one's right. 6 should just be 5, right? Okay. Yeah, let me fill this out. So 1, 3, 4. Right, this is 0, 2, 3, yes. Oh! Sorry, trying to feed the cat. I forgot. Yes. New food. New party. Cats love it. I can hear the difference. Alright, we're just trying to figure out why this is not right. 1, 3, 4. 0, 1, 2, 3, 4. Yeah, 0, 1, 2, 3, 4. 5. 0, 1, 2, 4, 5, not 3. I don't have 3. Four. 0, 1, 2, 3, 5. 4. 0, 1, 2, 3, 5. Yeah, 0, 1, 2. 3, 5. 3, 5. 5. We only have 3 of them. 3, 4, 6. 3. Yes, 4, 6. And 6, of course, we only have 5. Okay. So, yeah. So we're gonna start from 0. Let's see. You already add everything. That is not. That's not what I want. I have to redo it. And I need to step in. All right, step in, step in. Step into. Okay. All right, so memo index is 0, so 0, 7, right? So 0 at the front, we need to go 7. Let us know. This is null, right? So scene 1 left shift 7. 1, 2, 3, 4, 5, 6. Ooh, maybe that is the problem. No, that's index. Index, that's fine. The 0 is only shift. It's not shifting index. Wait, it is shifting index. Yeah, because we want to see if this one's seen, right? So the 0 just shifting 0, so it should be 1. Yeah, it should be fine. The 0 shall seen as 1, right? So 0, so neighbor. 0 can be. Oh. No. No O. It's not itself. So we're going to go 1, 3, 4, right? So the neighbor is 1. Neighbor can go 1. So 0 can go 1, right? And then go 1. Then we will step into again. Yeah, step into. Index is 1, right? Go to 1. And then that's also 1 shifting 1. So we go from 1. 1 you can go 0, right? But so if you can go 0, it's nothing because 0 has seen already. So next neighbor is 2, right? So you go 2, and from 2 you can go 3. From 3 you can go 4, and from 4 you can go 5. From 5 you can go 6. That will give you 1. And then of course, I think maybe I'm counting duplicates. Maybe I'm counting duplicates? Is that what it is? I'm finding uniques, okay? Starting from an index with this length, I want to find the total number of uniques. Yeah? I don't see any issue in this. May we print out the and let's just step in. Right, now index is 2. Go, 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 go. Index is 2. Index. Neighbor is 3. Right, neighbor is 3. Show you all F7. So neighbor is 3. Okay, neighbor is 0. Neighbor is 1. Neighbor is 2. Neighbor is 4. Okay, for neighbor is 1, 0, 1, 2, 3. Now neighbor is 5. Go, 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 go. Neighbor is 3. Neighbor is 4. Neighbor is 6. I'll go in. Boom, neighbor is 6. And then there's the last one. So that's return 1. Yeah, I think that's correct. Right, it's correct. Which means start with 5. Right? You start with 5 with 2 left. That's it. Start with 5 with 2 left. You only have 1. Index of 5, length is 2. Yeah. What was the problem? I think they love it. Finished all. What was the problem? Okay, this is not gonna help. I need to print. Basically, what I need to do is, after we go through everything, let me just print. Okay, how do we print? Array.toString, right? Okay, so we say for integer row of dp. Memo is int. Int row of memo. No, memo is not. It's integer. Awesome. System.out.println arrays.toString row. Okay. Run this. Okay. Let's take a look what we have. Yeah, maybe it's easier if I just translate this into this, because I need to examine. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Actually, we need 7 because the length is 7. Right? Because this should be 7. 1, 2, 3, 4, 5, 6, 7, 7. Yeah, 1, 2, 3, 4, 5, 6, 7. 8. Yeah, it should be 8. That's correct. So basically this is 6, 24, 28. Oh, 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. All right, 28, 8, 2, 24, 6, 2, 1, 31, 8, 3, 1, 1. Huh, we have a 0. And 16. No, 31. 31, 8. Oh, we have a duplicate. Hmm. 16, 3, 1, 1, 0, 1. 0, 0, 0, 0, 0, 3. So I am way too big for the answer, right? Answer is 48. I'm 109 too big. 109 too big. Jesus. I don't know. All right, we just check the smallest, okay? We'll never have 0 at the front with 1. Okay. 6 at the front. 2. No, number 6 at the front with 2. That's a 0? Are you sure? Because I can do 7 and 70. Oh, but 70 is seen before. 70 is seen before. Yep, I think this method requires a 3 level. It's a 3 level DP. That's a 3 level DP. Ugh. 3 level DP. It's alright. It's alright. We are going to do it. It's a 3 level DP. We'll do it. Hold a second. Oh, yes, the bike. No problem. No problem. Yeah, gotta do a 3 level DP. I thought I can avoid it. A 3 level DP. Boy, I was wrong. I cannot avoid it. Now I feel cold, so I think I'm gonna put on my pants.
Oh, you have no layers, okay now.
Yes.
Oh,
Sorry.
what's the layer?
No, you don't have to. cat. Alright, I'm back. Yeah, it's a 3-level DP. Well, thought I can avoid it, but cannot. So for 3-level DP, that simply means this has to be another one. And this has to be, what's this one? N. 1 left shift N. Right? The total, not really. It's 1 left shift. Yeah. Index is n minus 1. So one of shift N minus 1 plus 1. Yep. So it's that. And that's fine. I probably don't need this. I mean, you're not gonna need this anyway. Okay, page up. So basically, these are all fine. This is fine. And this has to be also seen, right? If I've used it before, then I'll return seen as well. If I haven't, I get a scene. I do this, and then we'll put scene in it. Right, so we'll put scene in it. I don't know, this isn't be right. 48. That's it. That's correct. Page up. I thought it's gonna add a lot of overhead. Like, I thought it would be hard to program, but it turns out, it's not that bad. No, it's not that bad. Put this one here. More test cases. Yeah, it shouldn't be that bad. All it does is... What? What? That's bonkers. Hold on. Wait, is these two timeout? These two are fine. No way. This one times out. Huh. That's not right. Now what? So it's not that. But the other one is because we don't have scene. Alright, it's been a while, so I'm going to think about it again. Yeah, definitely not 3 levels. 3 levels is going to time out. 3 level is going to time out. I don't understand why it would time out. It's not that much. Right? It's not that much. Now, I still think it's going to be 2 levels. But the thing is, when you hit we can try. Yeah, it's not gonna work. Yep, exactly. Exactly. Oh, we didn't even consider 1. Everybody is divisible by everybody else. So when that happens, it's a different situation. Okay. Well, we'll do this tomorrow. All right. I'll see you guys tomorrow. Adios.